Hello, grade 10s. In our last lesson, we learned about some of the properties we could determine from the periodic table. But one of the most interesting things that we learned was that because of an element's position on the periodic table, we could determine how many valence electrons it has. Remember, the outer shell in a Bohr diagram is called the valence shell, and the electrons found in it are valence electrons. And since the only electrons that can be involved in chemical reactions are the valence electrons, it makes sense that there could be a different way to represent atoms that would be easier and more convenient for us. So that easier and more convenient way that we are going to use to represent valence electrons is called Lewis structures. When we draw a Lewis diagram, also called an electron dot diagram, it's a shorthand way to represent the electrons that are in the valence ring. So we do a couple of other things to make it simpler. We will draw just the valence electrons and we'll draw them as dots. But rather than all of the inside rings of electrons and the protons and the neutrons, we're just going to use the chemical symbol for that element in the center to say all the rest of that stuff. So, for example, I have the Lewis dot diagrams drawn for every element in period 2 as we go from lithium to beryllium all the way across the periodic table ending at neon. We know, for example, if I were to draw a Bohr diagram for lithium, that because it has atomic number of 3, it would have 3 protons in the middle. And because it weighs almost 7, it would have to have 4 neutrons. That way that total mass was equal to 7. In the first ring, it had 2 electrons, and in its outer or valence ring, it had 1 electron. Now this is lithium, and that's a lot of work just to draw lithium, especially since only this electron is the one that's available for making bonds. So the easier thing to do is to say, because lithium is in group 1, it's an alkali metal, we know that it will have 1 valence electron. And so I draw the symbol Li for lithium, and I draw just 1 dot, representing the fact that there's 1 valence electron in lithium. Beryllium, being in group 2, would be Be, the symbol for beryllium, and then 2 electrons. In boron, we put 3 because it's in group 3. Notice how I'm arranging the electrons around the element. It's kind of like following the hands around a clock. When I'm putting electrons, valence electrons, in a Lewis dot diagram, I typically start with 1 on the top and then work my way around clockwise. The second one, if there was 2, would go here, the third, the fourth, and then we start to pair them up. We'd put electron number 5 here, 6, 7, and 8, so that we end up with 4 pairs of electrons, as we have here in neon. So we do this because eventually what we're going to find out is that single electrons, ones that are by themselves, are available to bond and have a reaction with another element, but paired electrons are not. You'll notice in the noble gas neon that its valence shell is full with 4 pairs, 8 electrons. It doesn't have room to react with other elements. Oxygen, in group 6 on the periodic table, has 1, 2, 3, 4, 5, 6 electrons. These 2 electron pairs are not available for bonding. These 2 unpaired or single electrons are, and oxygen can make 2 bonds. Oxygen, for example, when it bonds with hydrogen to form water, we see here in blue that oxygen has its 6 valence electrons. Hydrogen, being in group 1, has only 1, and so hydrogen's 1 electron pairs here with oxygen's single electron. Hydrogen from another atom will pair a single electron with this one. In this case, there are 2 hydrogens and 1 oxygen. Hence, the formula for water is H2O. Now, remember, we told you that the number of valence electrons, and so the number of dots you'll draw, is always the same as our family number, the tall vertical columns. This is true for everybody except helium. Well, why would helium, even though it's in group 8, not have 8 electrons? We answered this in the past video. Helium only has 2 electrons available to it. So helium has 2 electrons, and because it's still a noble gas and it can't bond, helium's a bit of an exception where I would draw its 2 electrons side by side. Now, in reality, it doesn't matter where you start counting. In this case, I started counting on the side. I could easily have written it this way. All that matters is that we pick a position to start drawing our dots, and then we work our way around the clock clockwise, doubling them up as needed until we get to 8. So the chemical properties that an element has actually gets determined by these valence electrons. Like I said, they're the ones available for bonding. We know oxygen's at atomic number 8, and it has 2 electrons in its first ring and 6 in its second. Again, it has a Bohr structure. I would say there was 8 protons and 8 neutrons because it weighs 16. And in the first ring, I have the first 2 of those 8 electrons, and then that ring is full. And in the second ring, I'll put the next 6. 1, 2, 3, 4, 5, 6. And so a Bohr structure, again, takes up a lot of space. Lewis gave us the shorthand way of doing it. The easiest thing for me to do, rather than drawing the Bohr diagram first, is just to go to find out which family number it's in. And we know that oxygen is in family number 6, so that means it's going to have 6 electrons when we draw a Lewis diagram for oxygen. So the rules for drawing Lewis structures is we're going to do the shortcut, and we're going to find out which family number it's in, and that will tell us how many valence electrons. And I'm going to draw 1 dot for each electrons up to a maximum of 8. Now, in your notes, you have this little chart. We're going to try doing a few of these together. We can see in the first example that sodium, symbol Na, has atomic number 11. There'd be 2 in the first ring, 8 electrons in the second, and 1 in the third. The outermost shell is your valence electrons. There's only 1, and so we draw 1 dot. For aluminum, whose symbol is Al, with 13 electrons, the first ring's full with 2, the second fills with 8. We still need more, so we go to ring 3 for 3. Would have 3 valence electrons, and aluminum's in group 3. So the Lewis structure for aluminum is to draw 3 electrons. Argon has 8 in its outer shell. To draw argon, we go 1, 2, 3, 4, 5, 6, 7, 8. This is a great place for you to pause the video and see if you can answer the last few of these on your own. When you're done, press play, and I will show you the answers. Okay, we can see that chlorine had 7 electrons in its outer shell, and it's in group 7. So there are 7 valence electrons, and I draw 7 dots around the symbol Cl for chlorine. Just like silicone's outer shell has 4 electrons, so there are 4 valence electrons, and I will draw 4 dots representing those 4 valence electrons. Now, you guys need to practice this so you can remember it. The end of this booklet has a small task where you practice figuring out how many valence electrons each element would have, and then draw the Lewis structure for them.